aboard a Soyuz rocket tonight, flight number VS-19.
In Darmstadt. I don't know if you can see it because it's dark in the room, but our room here is jam-packed with people eager to see the liftoff of MetOp C. And if the camera can show them, we've rehearsed that before. We all wave and say hello to Kourou now. So this is for you, Katie, and the team in Kourou. And of course, we're not here on our own. We also have some very important people here also on stage. For example, the CEO of Arianespace. He's not in Kourou. He's here with us in Darmstadt, Stéphane Israël, and of course, our host, EUMETSAT Director General Alain Radier. But Stéphane Israël, tell us a little bit about today's mission, if you would.
Yes, so today's mission is very important for us because it will be the 13th satellite we are going to orbit for EUMETSAT. The first one was in 1981 with Ariane 1, so it's a long history we have together. We have orbited MetOp A and MetOp B in 2006 and 2012, and tonight is the night of MetOp C.
And the next few hours, not the whole night, what's going to happen?
So maybe what has happened in the last hours, we have 5 hours ago made the decision to fill the rocket. We have made this decision on the basis of the readiness of all systems, but also on weather forecast, which are very positive for tonight. So the rocket has been filled, and now in a few minutes at 9:47 Kourou time, we are going to launch the rocket. The mission will last a few seconds more than 1 hour. We will lift off towards the north, which is not usual because usually when we go to GTO we lift off towards the east, but for polar orbit we lift off towards the north. We will have during 9 minutes the flight of the 3 stage. After these 9 first minutes there will be the separation of the frigate, and then the frigate is going to work for 51 minutes with 2 burns, and the separation will occur after the second burn, and we will deliver the spacecraft at an altitude of 817 kilometers.
And why, Alain Radier, is all of that important for EUMETSAT?
For EUMETSAT, first of all, it's the last satellite in a series, and this is always a very important satellite to prepare the transition with the next generation. And as you know, we are already developing this new generation with ESA. It's MetOp second generation, but MetOp second generation is a pair of satellites with different instruments on each one. And in fact, the full pair will be deployed and available and operational in orbits in 2024. So you understand how important it is for MetOp C to work until then and beyond. It's also very important for us because, as explained already, we will, for the first time, operate a constellation of 3 satellites. And it's not so easy. Mike Williams said they work alone together, but he's very modest. We have developed a new ground segment, and one of the stakes of this new ground segment is also to operate at the same cost as if we had only 1 satellite. So that's also a technical challenge.
Sure. And we've just heard some user experience. I mean, what does this launch tonight mean for the Met community?
I think you have heard so much that I would not repeat, but maybe I can translate the impact on weather forecast into socioeconomic benefits, because we have done a number of studies on this. And today, the socioeconomic value of forecast in the EU is more than 60 billion euro per year, out of which we can attribute 5 billion euro per year to these satellites. So you see what is at stake.
Absolutely.
It's not only to know whether it will be good to go to the beach in Kourou, but it's also very important for the economy. There is no civil aviation without this type of forecast.
So
you have heard the cycles.
A lot of everyday things that we need for the economy depend on the data we get. And in order to get the data, we need a lift-off. And for that, not quite yet for the lift-off, but for joining the Arianespace program again, I would like to hand back to Katie at Mission Control Center in Kourou. Katie, over to you.
Thanks very much indeed, Monica. Yes, indeed, we are roughly about 12 minutes to launch now, just a little bit over. And we have with us here in the Mission Control Center the senior consultant here at UMETSAT, Mark Cohen. Mark, thanks very much indeed for coming to the floor. Mark, it's been quite a few years getting ready for today to launch MetOp, but we are on the pad, so does that mean you're ready?
Oh, yes, we are completely ready. The launch campaign has been very long, has involved a lot of teams from industry and from agencies, also with the launcher team, but we are ready today. Today we have a green status.
Good, you're ready to fly. And
yes.
We saw there a number of your teams and your colleagues at the event in Darmstadt at UMETSAT. Any messages for them?
Oh, the message is that we are prepared the satellite here with a lot of care. It's going to be launched tonight, and then it's going to be handed over to them. And the first two satellites were very successful, and the third one will come over and will bring its contribution, which is expected by the member states and by the users. So that's the message.
Great, and of course we've been hearing how important MetOp is as a part of the threesome. But just briefly, we often talk about satellite campaigns and projects as being teamwork, but this has really been a big collaboration effort, hasn't it?
This program was built around cooperation, so cooperation with the worldwide, with the United States, with the exchange of instruments, data and services, but also in Europe with industry, but with ESA, with National Space Agency like NES for some instruments.
Thank you very much indeed, Mark. I'm going to send you back now to your place in the fishbowl behind us to continue your operational work. Now, a number of teams here at the Mission Control Center and a couple of key people who we need to look out for.
Pour le I0 moins 10 minutes et 20 secondes.
And this,
la séquence finale lanceur.
and that was the range operations manager who just announced a key milestone there in the launch. It's the last 10 minutes and 20 seconds before launch when the frigate upper stage, as you remember I said the vehicle is divided into 4 stages. The upper stage is called frigate, and that has now entered the final phase of its launch sequence. And those operations are being reflected in the status panels that you can see there on the right-hand side of your screen. The computers are now handling a very complex set of operations, and those are shown here, all the systems showing us. Red is stop and green is go. So right now we are go for launch. Now we have a 1-hour journey ahead. We're going to take a look now at what's going to happen.
After a 9 minutes and 20-second flight, the action of the 4 boosters, the second and third stage, shall position the upper stage frigate and MetOp for a first burn at 10 minutes and 24 seconds after liftoff, lasting 3 minutes and 16 seconds. Will follow a ballistic phase of 38 minutes and 43 seconds. A second burn will occur at 52 minutes and 23 seconds, lasting 1 minute and 15 seconds. This will be followed by the ballistic phase, lasting 6 minutes and 30 seconds. MetOp C will be released into the dedicated orbit 1 hour and 18 seconds after liftoff.
The satellite arrived here at the Arianespace Center on the 26th of June, and teams have been preparing ever since then for today, apart from a break over the summer holidays. So it's been quite a long launch campaign. The launch campaign is what we call the process of preparing the launcher and the satellites for today. And we're going to get an overview now of some of the activities that the teams have been doing during the launch campaign.
The launch campaign has started with the arrival of the first Antonov cargo plane on the 19th of June. The spacecraft arrived on the second and third cargo plane in 3 different containers and was transferred to S1 payload facilities with ground support equipment. Mechanical and electrical checks have started right after the arrival in S1. Spacecraft projects had a standby period during the summer, then final preparations were performed before spacecraft transfer to S3 fueling facilities on the 2nd of October. MetOp C has started propellant filling operation on the 8th of October. Fueling operations were performed until the 11th of October. Combined operations with launcher have started on the 19th of October with flight mating on payload adapter. MetOp C was transferred onto the frigate stage on the 25th and encapsulated under fairing on the 30th of October.
In parallel of the frigate preparation, the 3 stage underwent the standard pneumatic and electrical tests in the MIC building, the facility for the launcher integration and testing. Also, additional mechanical controls were performed, which involved dismounting of the lateral boosters and the reattachment on the record stage. As elements of the next Soyuz launchers were already deployed in the MIC building, some complementary movements of the launcher blocks had to be performed to allow the operations for up to 3 Soyuz launch campaigns in parallel. The rollout of the 3 stage from the MIC building and transfer on the launch pad has been performed on D-3 last Friday, as well as the transfer of the upper composite with MetOp C and frigate from the S3B onto the launcher. Dress rehearsals of the spacecraft, the 3 stage and frigate were successfully performed on D-2 and D-1. Once the ground installations and the launcher are prepared, we should conclude with the fueling of the launcher starting at H0 minus 4.5 hours and the final chronology phase before liftoff. A special thank you goes to all the operational teams for their huge efforts and contribution to take us through this very smooth launch campaign.
The Soyuz launch readiness review held on Monday, November the 5th, authorized the beginning of the final chronology today to launch the VS-19 mission.
So I'm back in my commentary box now, which is in the Mission Control Center, and we are 5 minutes 36, 5 seconds to launch. And we actually have 2 synchronized sequences. The first one we saw earlier for the frigate upper stage has already started, and we're coming up now to the start of the final phase of the synchronized sequence for the main launch vehicle, so the first 3 stages. That's at 5 minutes and 9 seconds. So what we're looking at here is the outside of the Jupiter Control Center, the Mission Control Center, the nerve center, if you like, of the spaceport. And these are the teams inside there. Now, every launch zone has a launch control center, and this is the launch control center for Soyuz. We have a number of different teams working in here. And of course, because Soyuz is a Russian rocket, we have joint Russian and European teams working side by side. And the teams in here are responsible for everything to do with the launcher, the rocket, and the launch base. So making sure that the launch site operations are all done correctly, and being responsible for the flight readiness of the vehicle. In Baikonur, in Kazakhstan, at the Cosmodrome there, the Launch Control Center is actually in several bunkers underground. That's about 50 meters from the pad. Here, at the Arianespace Centre. It's in a protected building 1 kilometre from the pad. Our passenger MetOp C is the last in the current series of MetOp satellites, as we were hearing, waiting up there inside the vehicle for liftoff. A joint programme of EUMETSAT and the European Space Agency, along with their partners, the French Space Agency CNES and the US National Oceanic and Atmospheric Administration, NOAA. Now, when we get to look at the rocket, actually you can see it on the screens, there we have it. Have a look at the bottom, you can see those 4 swing arms there are blue. Now, they are holding the launcher suspended over the flame trench on the pad, and they stay in place because the weight of the launcher is on top of them. But of course, as it lifts away, they will swing away thanks to counterweights on the back of them. You can see them there. At the bottom of the swing arms, you can see the yellow cylinders. Those are the counterweights. Right, he's just announced that we have separated the umbilical lines, which are actually inside that grey mast, so you can't see them. The grey mast is called the KZM, and it houses all the connections, electrical, etc., connecting the upper parts of the launcher to the teams on the ground. And then underneath it is another mast called the VKM, and that's hosting a whole set of other connections. We'll see both of those pull away just before launch. A word about the ignition sequence. We switch on the engines on Soyuz 16 minutes before seconds rather, before launch. And that's done on purpose so that we can throttle them up gradually and check that all the engines are working correctly. And then once they reach full thrust, the vehicle leaves the pad and those swing arms pivot away. These are all the guests in the Mission Control Center coming out to have a look at the launch with their own eyes.
Attention pour le I0 moins 1 minute. Top I0 moins 1 minute.
We are 1 minute to launch and we're live at the Arianespace Centre. We're launching MetOp C for EUMETSAT and its partners, ESA, CNES, NOAA, built by Airbus Defence and Space and all the industrial teams involved in that. And we're travelling on board the 19th Soyuz to launch from the Amazonian jungle, the 8th launch this year from the CSG. There goes that mast.
Attention pour le début de la séquence d'allumage lanceur.
Our best wishes to the teams.
Top I0 moins 20 secondes. Largage du mât VKM, allumage, triétage à tous les vidéos. Attention au décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top décollage.
We are off. MetOp C has started its journey, flying through the very atmosphere that it's going to be sending us information about. We're heading out north over the Atlantic. And he's telling us that everything's going according to plan. Of course, MetOp is going to orbit our planet north to south, so we are going to deliver it on a polar orbit. We're burning 20 engines at the moment. We've got 4 on the core stage and 4 on each one of those boosters.
Stabilisation correcte du lanceur.
Stabilisation is correct. And the boosters are doing all the work. They only burn for 2 minutes, but that's long enough for Soyuz to escape the pull of our planet. They are delivering 80% of our thrust right now. Their job, to get us away from Earth's gravity. Gravity, of course, makes us stick to our planet, but it stops us from flying off into space, but it also makes it very hard for us to leave. So we need an awful lot of firepower to do that. And we can see those 4 boosters now being jettisoned.
Séparation du premier étage.
And we have confirmation there from the Range Operations Manager. So we saw those with our own eyes, and we're now burning the main core stage, known as the Block A, and it's the engine that you can see there.
Stabilisation correcte du lanceur.
And the stabilisation is correct, all going according to plan from the Range Operations Manager there. Altitude on the bottom left of the screen, 85 kilometres above our planet. The distance, if we were to draw a straight line across the Earth from the launch pad to the position of the launcher, 131
Paramètres du système de commande du lanceur conforme à l'attendu.
kilometres. And our speed on the bottom right, that's kilometres per second, of course, ladies and gentlemen, boys and girls, per second. So we are already travelling incredibly fast, and we'll be getting even faster. Amazing to see such beautiful pictures of the launcher. So those clouds actually managed to move away just at the right moment. Coming up to the scheduled moment for the fairing to be jettisoned, the fairing being the front, the nose, the tip of the vehicle that we saw earlier, housing the satellite and protecting it from the rigours of the launch, things like the acoustic vibrations at launch, which are very loud, of course.
Séparation des 2 demi-coiffes.
And we have separation of the fairing, which comes in 2 halves, which is why he said separation of the 2 halves of the fairing. So our satellite is now exposed to space, and we are officially in space. We are coming up to 150 kilometres above Earth. We actually arrived in space when we reached 100 kilometres, which is the official Kármán line, the official boundary with space. Still following the launcher with our cameras, which is quite remarkable to see it now, 4.5 minutes going deeper and deeper into space. Our trajectory on the top right-hand side of the screen is the trajectory of the launcher, the planned trajectory, and the cross is the actual position of the launch vehicle. We're starting to get further away. You can see there we're now 175 kilometres high, and we can still see the dot of the engine. And we have separation there, confirmation from the Range Operations Manager that we have now separated the second stage of our rocket. Picking up speed, close now to 4 kilometres per second. All going well, all going according to plan. And here we have the Flight Directorate. As I mentioned earlier, we have a number of different desks in the Mission Control Center. This is the Arianespace top management team. They take all the final decisions in the event of any unplanned situations. And here as well we have the joint Russian and European teams sitting shoulder to shoulder. So we can see our satellite for the first time. There it is, MetOp C at the front. So if you've never seen a launch before, to the left-hand side is what remains of the rocket. Then it's sort of in the middle, just after that white fan section, is the frigate upper stage, the gold round circular structure. And then right at the front is the satellite, and it's all folded up, of course. Ready to unfold when it separates. We've launched a lot of satellites for EUMETSAT. Let's take a look at them.
3, 2, 1, feu, allumage, décollage.
Système de commande du lanceur pour à la pendule. Le moteur du troisième étage fonctionne manuellement.
So there you have it. Arianespace has launched all the satellites for EUMETSAT. Those were the 12. And today, of course, we are launching the 13th satellite, MetOp C. It's en route right now to its final slot in space. And there on the right-hand side, you can see we lifted off from the Guiana Space Center on the northeastern coast of French Guiana. And Galileo is the name of the tracking station here at the Guiana Space Center. We're using telemetry to track the vehicle. During the flight, Soyuz sends information to the ground stations along its flight path, and they then send that data to the teams here at the Guiana Space Center. And this allows Arianespace to monitor the flight in real time. It also means they can do an evaluation after the event and check out how it all went and see if they need to make any adjustments for future flights. So it's a very important process. And our telemetry stations tonight are Galileo. We saw that. That was the one in French Guiana. And then we'll be picking up the signal next in Bermuda in the Caribbean. Then we've got St. Hubert, that's in Quebec, and New Norcia in Australia. This is the scheduled moment when we pick up the signal in the tracking station in Bermuda. So the ground station...
de la télémesure par la station de Bermuda.
And we've just had confirmation of that there from the range operations manager. Our confirmations take a little bit longer to get to us. The ground stations send the information back to the CSG, the Guiana Space Center, but it has to go via Moscow to be validated first, so it can take a little time for it to get from the launcher to us for confirmation. That's the scheduled moment now for the engine shutdown.
Séparation partie haute.
Separation there of the third stage. And we're looking at these CGI images, computer-generated images, which are showing us what the experts have planned and calculated to be happening to the launcher and the satellites. So they are a simulation of what's happening in space. So we're looking at the frigate upper stage, that round circular structure back there. It's what's left of the launch vehicle, and it's getting ready to switch its engine on. We're in what we call the pre-burn phase. It's giving a quick burst of acceleration right now and pushing the fluids back into the back of the tanks to make sure there's enough propellant to ignite the engine properly. It's a little bit like when you press the throttle in the car and you get pushed back against the seat. And this is the scheduled moment now for the frigate upper stage to switch on its engine, which really signals the next phase in the journey when frigate takes the wheel. It's a bit like an orbital taxi driver. Its job is to deliver our satellite to its drop-off point in space.
Premier allumage, étage frégate.
And he's confirmed that we now have the first ignition of the frigate upper stage's engine. Some of the teams here in the control centre. If you look at the right-hand side of the screen, you can see the frigate upper stage there. It's that round circular structure with 6 spherical tanks, which are organised in a circle. 4 of those for propellant, 2 of those for avionics. That's the sort of thing that you find in the cockpit of a plane. Flight control systems, navigation, communications, that kind of thing. And the satellite is attached using a very special dispenser or adapter. The frigate upper stage is a really clever piece of kit. It was originally designed as an interplanetary probe to travel around the solar system. And it was adapted to fly on board Soyuz, and it can switch its engine on and off up to 20 times. And that's why it's able to take its passengers pretty well anywhere they need to go. And it makes Soyuz ideal for launching all kinds of spacecraft to all kinds of orbits, including constellations and, of course, observation satellites and meteorological satellites like today. We're using that engine twice today to separate our satellite. And that's our flight path.
Acquisition de la télémesure par la station de Saint-Hubert au Canada.
So we're now picking up the signal at the tracking station in St. Hubert in Quebec in Canada. It's just outside Montreal. I believe that the aerospace industry is very important there. The Canadian Space Agency has its head office in the borough. And we've been hearing how MetOp C is going to be providing important and accurate weather predictions from 12 hours to 10 days in advance. And it's going to give us vital information about the composition of the atmosphere, the oceans, the land surfaces.
Fonctionnement nominal du moteur.
Very important if we are to get a handle on how our planet's climate is changing, which I'm sure you all agree is absolutely paramount now as we see temperatures rising. Frigate getting ready to switch its engine off, and that's what it looks like. This is the scheduled moment for the engine shutdown, for the onboard computer to send the command. And this next phase of the flight is known as the ballistic phase. That means that we have no propulsion. Ballistic means travelling without propulsion and coasting without the engine. Sometimes we have very long ballistic phases, but for this flight it's not too long. It's about 38 minutes. And we're going to take a break in a second to while we wait for the ballistic phase. During that time, we will have a planned gap in visibility of the ground stations. That means that we are scheduled to lose...
Extinction du moteur frégate.
And we have confirmation there that the engine has indeed switched off. So, yes, we'll have a scheduled gap in visibility. That means that we are scheduled to lose the signal at the tracking station in St. Hubert. We've started the orientation manoeuvres. So we'll have a planned gap for about 20 minutes after launch, and then we plan to pick the signal up again at the station in New Norcia 31.5 minutes later. And that means that we won't be getting any information from the launcher during that time. Perfectly normal. It's all part of the plan. So, going to take a break. We will be back at 10:24 Kourou time, 1:24 Greenwich Mean Time, and 2:24 in the morning in Darmstadt. Let's look at the launch again. We lifted off 15 minutes ago from the pad here at the Arianespace Centre. This is what it looked like. See you shortly.
perte nominale de la télémesure par la station de Saint-Hubert et toutes les mesures prévues.
Hello again, welcome back. We are live at the Arianespace Center on the northeastern coast of Amazonian South America. And I've come onto the terrace on the outside of the Mission Control Center, which you're looking at there. You can see on the right-hand side the model of the Ariane 5 launch vehicle. We are nearly 38 minutes into the launch of MetOp C, which is heading out to its orbital slot in space, and it's riding bareback on what's left of the Soyuz launch vehicle on the frigate upper stage. We've been coasting without the engine for a while. We're in the ballistic phase. Now let's take a look back at what happened. We lifted off from the pad about 38 minutes ago. That's what it looked like. It was a superb launch and everything went like clockwork. We were lucky because although there were a few clouds at first, the skies cleared and we were able to see the vehicle for about 4 minutes with our cameras. After 2 minutes, the boosters were jettisoned, then the fairing, and then we switched off the second and third stages. And there we saw the final stage, the third stage, and the frigate upper stage then switched its engine on for about 3 minutes. And then it switched it off again, and we've been coasting without it now for about 24 minutes. It's scheduled to switch back on again in about 14 minutes' time. So that's what's happened so far. Now we are getting closer to releasing our satellite. Once it has separated from the mothership, it's going to go through a series of activities. We call these operations the LEOPS, Launch and Early Operations Phase. Let's go over now to the teams to find out what's actually going to be happening during that time.
Once delivered to orbit, following the separation from the frigate upper stage, after approximately 1 hour after launch, the European Space Agency Operations Center, ESOC, located also in Germany, Darmstadt, will acquire MetOp C and will lead it through the critical phase of the launch and early operations called LEOP and maneuver the satellite on its final orbit to line up with MetOp A and B. EUMETSAT will take over the MetOp C operations after around 72 hours from ESOC and is prepared ready for the operations to perform the satellite in orbit verification and instrument calibration activities. It is planned that MetOp C will be able to provide operational services by mid-May 2019.
Thank you, EUMETSAT, for your continuous confidence in launching meteorological European satellites with Arianespace, and we are looking forward to working again soon with you.
With Arianespace and its Russian suppliers, EUMETSAT has chosen a very reliable partner to bring MetOp C into orbit, and with the first-class launch facility services provided from the teams here at the European Spaceport, CSG.
So the teams at the European Space Agency's Operations Centre in Germany will be overseeing those operations for the first 72 hours. We hope to go over to them later in our programme. And then, of course, EUMETSAT teams will take over flying, effectively, their satellite until the end of its life. It's a well-rehearsed process, and MetOp C is going to play an important part when it joins its siblings in space.
For us, the success of a program like MetOp is the impact on the users. And the MetOp satellite are those who have the highest impact on numerical weather prediction. 44.5% of the impact of all satellites is due to the 2 MetOps.
Another success is, of course, the extension of the program. The program had a fixed budget, and we are able within this budget to give much longer service than initially expected. So the program is also extended.
The new satellite will help improve the forecasts. That's what we find with satellite data, that they improve the forecast quality. And we already have MetOp A and MetOp B. And MetOp one MetOp satellite is really the largest impacting satellite from the whole range of satellites we use in global numerical weather prediction. So they really make an impact. And what our data simulation systems are good at is actually combining data for different satellites. You would think they could be slightly redundant, but actually they all bring something to the forecast quality.
The meteorological community like the MetOp satellites, and the reason is simple. It's a polar orbiting satellite which has the most impact on the performance of weather forecasting. It's also important for the global community because it's one essential component of the World Meteorological Organization observing system. So it serves all nations, all users worldwide.
The accuracy of MetOp data on numerical weather prediction in the Met Office is quite profound. It is huge. We estimate that about 25% or more of the benefit to forecasts of all the observation data we use comes from the MetOp satellites that we have. So we're really looking forward to adding MetOp-C to that to help provide resilience to the global observing system.
We are part of a global observing system which is organized under the umbrella of the World Meteorological Organization, and we have recently convinced the Chinese to have a similar approach, so to fly their satellites on different orbits, because every time you fly on a different orbit, every time you have additional information which are valuable to the users, and as all this information is shared, it's clearly a benefit to our user community.
I would say the main successes of the program are that we have such a long-term data set over such a long period of time, that we can connect this data together, link it together with the different instruments, that we have achieved a very effective cooperation, institutional cooperation, but also industrial cooperation in Europe, but also with the US, which is very successful day by day. In these terms, we have been very successful bringing out the data to a global user community.
Yes, this is a very important launch, and because we secure a safe transition to the next generation, we will also have, with 3 satellites, a more valuable system for our users, and a more robust system, because, of course, when you have aging satellites, you may lose an instrument. It may happen. This is far beyond, MetOp-A is far beyond its end of life. So having more satellites in orbit makes the system much more robust. So we are sure we can deliver the basic mission, and everything extra is bonus. This launch is a bit special. It's special because this time we launch in Kourou. And needless to say, we fully trust Arianespace. It will be the 13th launch with them. And of course, we cross our fingers, but we fully trust this will be a successful launch.
Every satellite is made by a group of industries working together, and you can see there, I'm going to wave at you. Our drone is looking at me, and I'm on the terrace here outside the Jupiter Control Center. MetOp-C was made by a consortium of industries led by Airbus Defence and Space, and they've equipped MetOp-C with some very advanced technologies. Let's take a look. So really advanced technology, as you can see there. And during that film, we were scheduled to pick up a signal at the new Norcia tracking station. Soyuz checks in with the teams when signals get picked up. So, getting closer now to the next phase, which is the scheduled ignition of the frigate upper stage.
Here we're on the roof of Sorbonne University, and this is the antenna where we receive our data from the YASI instrument.
And no fewer than 2.5 million items of data come through this antenna every day. Data from the 2 YASI instruments developed by CNES in partnership with EUMETSAT that are flying on Europe's MetOp weather satellites. The YASI instruments are giving scientists precious insights into Earth's atmosphere.
We have codes for decrypting the data and converting them into gas concentrations. What we're doing is monitoring these concentrations over time. In other words, their variations or spatial distribution, how they're carried by the winds, and where pollution peaks are moving, so that we can track them and send out alerts in the case of exceptional events like big wildfires, volcano eruptions, or industrial disasters. It's also conceivable that we could send out alerts with our maps, since we receive the data in near real time.
With its roughly 12-kilometre field of view, the YASI instrument scans the atmosphere from its vantage point in orbit. Its objective is to measure thermodynamic parameters and levels of different gases in the atmosphere. And since the first instrument launched in 2006, YASI has brought scientists plenty of surprises.
But it's also a great asset for atmospheric chemistry and climate applications, as we weren't expecting to obtain all the results that we have. For example, the ability to measure ammonia is a surprise, and through scientists' research, we've been able to highlight a very interesting signal from YASI.
YASI is also contributing to Europe's Copernicus operational climate monitoring services through analysis of carbon dioxide and methane data. This research is being conducted by the LMD Dynamic Meteorology Department. The project originally planned to look at only 10 or so gases. Today, scientists are able to measure more than 25 atmospheric components very precisely, providing valuable support for climate monitoring efforts. What's so good about the YASI instrument is its ability to detect so many things in the atmosphere and Earth system. For weather applications, for example, it's capable of measuring atmospheric temperature and humidity. And for oceanography, it's helping to measure ocean surface temperature, which is important when tracking the formation of storms. YASI can also help to measure land surface temperatures, which is crucial for studying Earth's convection processes. So YASI lets us look at every element of the Earth system, and that's absolutely vital. YASI provides more than 60% of the data that Meteo France needs to generate its weather forecasts and monitor climate more closely. And with the arrival of the third YASI instrument in orbit, scientists will be able to draw on a record of more than 15 years of data to build a comprehensive picture of our atmosphere's composition and better understand and monitor global warming.
And we've had confirmation now that we picked up the signal at the new Norcia tracking station. So Soyuz has checked in with the teams there, southwestern Australia, and it'll be no doubt downloading a pile of information and data about the flight over the last half an hour or so. And the tracking station will then send that to what's called the CVI here at the Arianespace Centre, the teams who then go through the information and monitor the flight in real time, as well as looking at the information and analysing it after the event. So we now have the scheduled moment when we switch on the frigate engine for its second burn. And that's what it looked like. Just take a look at our trajectory up there on the right-hand side. We've really climbed into space. And confirmations, just a reminder that the information goes via Moscow, where it has to be validated. So the tracking stations send the information, it then has to be validated in Moscow, and then it can come back to the teams here at the Arianespace Center, where the range operations manager then announces the confirmations to the teams all across the base. And there he is. He's called or she is called the DDO in French, or the range operations manager in English, because the range is very big and it includes not just the spaceport, but it includes all the tracking stations along the flight path, and everybody has to tune in and listen to the voice of the range operations manager. Scheduled switch off time for the frigate upper stage. So this is the scheduled second ballistic phase. We had 2 ballistic phases for this launch, and the ballistic phase here is the part where the orientation maneuvers can then start. The 3 polar orbiting meteorological satellites in the MetOp series were developed by the European Space Agency ESA, and as we've been hearing, they are being operated by EUMETSAT, and MetOp-C is the 3rd and final one to be launched by Arianespace before the entry into service of MetOp, the MetOp SG series. So let's go over now to the European Space Agency to find out more.
In a clean room at Europe's spaceport in Kourou, MetOp-C is being prepared for launch. 6 years after the launch of its predecessor, MetOp-B, the satellite will now join the other 2 MetOp satellites in polar orbit. MetOp, or the Meteorological Operational Satellite Programme, is a collaboration between ESA and EUMETSAT, the European Organisation for the Exploitation of Meteorological Satellites. And it forms the space segment of EUMETSAT's polar system. With the launch of MetOp-C, EUMETSAT ensures the continued delivery of satellite observations and data services for weather prediction and climate monitoring to its users.
The main purpose of MetOp is to provide data for the numerical weather prediction. So essentially, MetOp is providing temperature and humidity profiles on the atmosphere, as well as wind speed and direction over the ocean.
MetOp data can be used to make weather forecasts ranging from a few hours up to 10 days. In fact, the contribution of these polar orbiting satellites is so great that they account for 30% of the precision of numerical weather predictions. Together with the geostationary Meteosat satellites, they form Europe's pillars for operational meteorological satellites. Since the launch of MetOp-A in 2006, the satellites have already gathered 12 years of continuous data on climate and weather. These long-term datasets are important, as they form the basis for monitoring our planet over long periods of time. They help us to better understand phenomena like climate change. To observe our planet from space, the MetOp satellites are equipped with no less than 13 different observation instruments, some of which are identical to instruments flown on the American NOAA polar orbiting satellites.
As part of what we call the initial joint polar system, so in 1998, EUMETSAT and NOAA signed this cooperation agreement where 3 European satellites, so 3 MetOp satellites, were corresponding to 3 US satellites, and for these satellites we share instruments so that the users get information from both satellites, the same types of information. So we try to create synergies between US and Europe, more benefits to our users.
One of the most important aspects of the MetOp platform is the synergy between its instruments. MetOp data from different instruments looking at the same area at the same time allows meteorologists to derive a wide range of crucial parameters for numerical weather models, such as temperature and humidity. Originally, the MetOp program consisted of 3 successive satellites to ensure continued data and services, whereby each satellite had an expended lifespan of 6 years. But with the launch of MetOp-C, Europe will soon have 3 working MetOp satellites in orbit, with MetOp A having already doubled its projected lifespan. With MetOp C, this data collection will be expanded even further and well into the future.
The MetOp were planned for a lifetime of 5 years. The first MetOp was launched in 2006 and still working very well. So now we are going to launch the third MetOp. The purpose of the third MetOp is to ensure the continuity of this data until the launch of the next generation of MetOp, MetOp SG, which is currently in development and will be launched in 2021-22 timeframe.
With MetOp C soon in orbit and MetOp SG, or second generation, in development, the accuracy of numerical weather prediction and climate research will continue to improve. Looking at different use cases for weather data, the social and economic importance of weather and climate can hardly be overstated. These govern our daily lives in transport, agriculture, and disaster management. Satellites like MetOp keep us safe from space.
So, some interesting information there about the satellite, but right now back to our launch, 59 minutes and 16 seconds. The Range Operations Manager confirmed that we've started the orientation maneuvers in order to separate our satellite. Some people like to call this process the space ballet. It's the process by which we maneuver the satellite into exactly the correct orientation, the right position, so that we can separate it onto a perfect orbit. All very carefully planned and all very precise, of course. And these CGI images are a simulation of what's happening in space, so even though, of course, it all looks like it's going very slowly, in reality we are hurtling through space. Look at our speed, nearly 8 kilometers per second. Getting closer now to the scheduled moment of separation of our satellites. That's what it looks like. We will wait for confirmation from the Range Operations Manager, but you can see there the satellite moving away from the
séparation du satellite MetOp C et attente confirmation de l'acquisition par l'équipe projet.
So he's announced we have separation of MetOp C, and we are waiting now for confirmation from the project team.
Confirmation de l'acquisition du satellite par les SOC à Darmstadt.
And he has confirmed that the satellite has been acquired by the Darmstadt teams. So good news, some very happy faces here. We're going to now go over back to Darmstadt, where the EUMETSAT event is ongoing, and over to Monica Jones. Monica.
Thank you, Katie. And when we just received confirmation of separation, I already feared that I would not be able to hear you anymore, because we had a huge round of applause and a lot of happy people here standing up, embracing. So you see, you know, the later the night, the higher the emotion, but that is really good news. And I would like at this point to go straight over to the ESA main control room to check with Valeria Bozzi and Hervé Kom, to see if they can tell us anything already about the signal acquisition, which should happen shortly. Do we have Valeria and Hervé standing by?
AOCS configuration at the beginning of the automatic sequence correctly executed. Copy, very good.
Very good. Okay. They're still waiting,
Soyuz, yes.
AOCS go.
Soyuz is nominal PSO computation at separation, nominal delta with expected values 0.1 degree. All 4 gyros are on as expected, with gyro 1 and 2 in use. Thruster preheating has been switched on. separation rates below 0 decimal.
Well, we were told earlier that there will be a lot of tension in the main control room, and I say that when I look at Valeria and Hervé, the tension is written all over their face. But she does have a microphone, and he's grabbing it now. Hervé, do release us from our misery.
Yes. Okay, so I confirm that we have seen separation from the spacecraft. We have acquired the spacecraft. The injection seems to be at first time pretty good. The deployment of the solar array has been started. We are the spacecraft is actually firing the thermal knife, and everything seems to be nominal. The separation rates were below 0.5 degrees per second, which means that the attitude is pretty good also. So everything is fine so far.
Super.
And just to let you know, over the next 45 minutes, we will continuously follow the deployment of the solar arrays through our ground station. Kerguelen from CNES, France. Troll from KSAT, Norway. Santiago du Chile from SSC, Sweden, and Esa Kuru from ESA.
Okay, so it's...
I hand over to Valeria, who will...
Please, Valeria, do share your thoughts with us now.
Hi. Well,
Hi.
Hervé said most of it. I would like to congratulate to our team in Kourou for the excellent job. Certainly all the intense work and the preparation paid off. Thank you very much. And now it's on us, and we start. And we also prepared a lot, and people are ready. There is a very good mood. Everyone is very focused and concentrated, and so good luck again to everyone.
Well, thank you. Thank you, Valeria, and thank you, Hervé, and good luck and a good night's work over to the entire team at the ESA main control room. All the best to both of you and the team. Thank you.
Thank you.
Yeah, thanks a lot. I think we can say we have a mission.
Sorry, that got lost certainly in the applause. Could you repeat that, Hervé?
I think we can say we have a mission.
You have a mission, definitely, definitely, Hervé. Thank you. Well, I just checked the time. On my watch, it is now 2:54 here in Darmstadt. We've witnessed a beautiful liftoff. We have separation confirmed. Everything is looking fine in the main control room. A bit tense, very busy. They have a long night and quite a long few days ahead of them, but they're in good spirit. And I certainly have seen quite a lot of very happy faces here on the sofa and all around. But the happy faces sitting on the sofa, I would like now one after the other to come up on the stage and share their happiness with us, starting with Stefan Israel, Arianespace Chief Executive Officer. Stefan, please.
So, ladies and gentlemen, dear friends of Arianespace and EUMETSAT, I want to say that it's a big year for Arianespace. After Galileo, after ADM, after BEPI, now it is a turn of MetOp C, and we are more than proud and happy to have delivered one more time for our European customers and our European institutions. You know that this launch is the 13th for EUMETSAT. And you may know or may not know that the space community is a bit, how do we say in English, superstitious. So I was not totally, how to say, confident because it was the 13th, but at the end of the day, it has been a very good number. And one more time, we have delivered successfully for EUMETSAT. After MetOp A and MetOp B, now MetOp C, we know how important it is for the Meteo community community. We know the importance of the partnership with NOAA, because this MetOp will be part of a constellation with NOAA. And so this is for us all the more important. All the more important also because one more time we have the illustration of what space delivers to the huge challenge of the 21st century, which is climate environment. And space is about security, is about connectivity, but space is also about climate and environment, and we have today the illustration of that. So I want to thank Alain Ratier for his trust in Arianespace. Alain is for us a key partner. It is with Alain on behalf of EUMETSAT that we have now 4 more EUMETSAT satellites in our order book. The next MetOp, who are going to be the next generation over the next decade, and also the next MTG. So 4 more satellites in our order book, and I really want to pay my tribute to EUMETSAT and Alain Ratier. I want also to express my thanks to ESA, Jan Werner, Joseph Aschbacher with us. As I have said, we have done a lot for ESA this year, and we are very happy to go on. I want to also salute CNES, who is part of this launch, NOAA, who is also part of this launch. After, it's important for us to mention a key partner for this launch. It is one more time this year our dear shareholder and friend of Airbus. Nicolas Chemussi is with us. In fact, every 2 weeks we have a meeting with Nicolas, either in Kourou, now in Darmstadt, and we will have next meeting up to the end of the year in Kourou, because it is a big year for us with Airbus. Tonight, I think it is a 122 satellite we have orbited, manufactured by Airbus. We have 20 more Airbus satellites in our backlog, so it shows to you what we have achieved and what we will achieve together. I want also to pay my tribute to our Russian partners, Roscosmos, and all the Russian partners of this success, the Center of Samara, Erkates Progress, NPO Lavochkin, which is responsible for the frigate at Senki. I want to thank all of them for their cooperation. Tonight is the 19th Soyuz from the Guyana Space Center, after 26 from Baikonur, and EUMETSAT knows that very well. So tonight it was the 45th Soyuz we do with our Russian partners, and we have always been very happy, very proud of this partnership. I want to thank for sure CNES CSG, who has perfectly helped us for this launch, and perfect monitoring of the weather, which was fully green tonight. And last but not least, allow me to pay my tribute to my Arianespace colleagues. We have a wonderful team in Arianespace, a wonderful team of people who are inspired by what they are doing, and we can understand that, because I think, to be honest, that one of the most beautiful jobs in Earth is to go to space. Thank you very much.
Thank you. Please do stay. Please do stay. Please do stay. This is the big happy family, the cooperation that we want to see. Next, please, Director General EUMETSAT Alain Ratier.
So, obviously, it's a great moment for us all, and I'd like first to thank Arianespace. EUMETSAT is a happy customer. No, but I think it's the third one on top of the Meteosat, and as you know, it's very important for the continuity of our service for weather forecasting. I would like also to thank all the teams involved. I think they are all represented here. ESA, NOAA, CNES, but also industry, Airbus, but Thales as well. Yazi is Thales. And I think it's also a beginning, because as you have seen, now the ESOC is deploying the solar array, so we are still, you say, mission to success, but now we need to bring our own mission to success, the satellite is in the safe hands of ISOC, and then we will validate the data, and we hope to open the service very in the early spring. I would like also, I was asked earlier this evening why this mission was important. I think it was important to people as well. There are a number of people who have spent quite a lot of time of their lives on this program, and I think I have to pay tribute to Mark Cohen also, because it's his last launch, but it's the third because he has gone through the full program. And there are also many others, but thanks to everybody, and we look forward to get the data and to deliver more to society. Thank you.
Thank you, Alain Rantier. Please do stay as well. Josef Aschbacher is the Director of Earth Observation Programs. It's your turn.
So thank you very much. I think this is a big relief for all of us, and it's really a fantastic moment. We have just seen separation and signal acquisition, and these are key moments, of course, in a launch. But I have to say that the work is not over. Our ESA people are extremely busy in ESOC, not very far from here. And it is now ESA's team who is working on the layup phase and making sure that the next important steps are working properly and monitoring the satellite and its functioning, especially deployment of the solar panel, switching on the various instruments. So there are still very tense moments ahead. And of course, from an ESA point of view, I mean, Stefan has delivered because he has put the satellite on the right orbit. But from an ESA point of view, we only are happy if all the instruments are functioning well, and we can hand over a very healthy satellite to EUMETSAT. So now we have seen the launch. I would also like to congratulate Alain, first and foremost, for being a fantastic partner in this project. And EUMETSAT is an extremely good partner in space with the European Space Agency and with many other partners. And this partnership has been proven and tested many years, more than 3 decades now. And we're working extremely well together. MetOp is one of these examples, but also we are preparing the next generations of satellites for EUMETSAT, MetOp second generation, as we have heard before, coming to launch from 22 onwards. Also MTG, not to forget, also the third generation of geostationary satellites, again, in a very close partnership with EUMETSAT. And I think this is really a highlight to show, to demonstrate this excellent partnership we have, EUMETSAT and ESA in particular. But let me also thank, of course, industry, Airbus, and Nicola is here representing the wealth of Airbus. Airbus has been involved in many aspects of METOP itself, but also, of course, in many other satellites which we have. We have just launched another milestone satellite with, again, Airbus as prime contractor, which is AELOS, again for meteorology. And Florence, sitting next to Nicola, is also eagerly awaiting the stream of data from that satellite. Just one word on AELOS. It really is such an incredible mission that it is showing how Europe is working and can work when all the forces are put together. We have delivered a world premiere in terms of technology. The UV laser is something which is extremely difficult and quite challenging from a technology point of view, but also filling a data gap, which is wind in cloud-free atmosphere, which of course for meteorology is critical. And this of course complements extremely well the METOP series of measurements. Let me also thank our international partners, NOAA and CNES, international CNES, of course, European, in particular, for their contributions to the instrument and the satellite. Of course, their instruments are crucial, and we have heard before what they are doing exactly. But let me also thank my own people, my own team in ESA. They have been working for a long time on this METOP project. Stéphane Carlier is the project manager. It is his last one. He will then be allowed to retire, but there are many people working in his team with industry to make sure that these satellites are functioning, that they are tested, that they are really doing what they are supposed to do, and this is not a trivial task. I can tell you, every satellite has its own problems and its own challenges, and he has done a marvelous job, especially reawakening the satellite after many years in storage and getting it out of it and making sure it all functions very well. So really thank you to my team in ESA to the project teams in Earth observation, but also to my colleagues in ESOC who are now working very hard, making sure that the satellite works extremely well and have done a fantastic job. And of course, thank you to Stefan for having delivered this fantastic satellite. We are working very well together. It's the third for us this year. We used to have one satellite every 3 years. Now we have 3 in 1 year, which is quite a challenge, and which is actually a sign also that Europe is extremely strong in Earth observation at the moment. And last, I'd like to thank my member states because they have been funding these satellites on our side. They have been giving us important financial support, of course, also on the EUMETSAT side, and both of us have been really showing that this can work well together. Thank you very much to all of you.
Thank you. Thank you, Josef Aschbacher. And of course, this is a very European mission, but with cooperation also in the United States. And we now welcome Mike Freilich, NASA Director of Earth Science Division. There he is.
Wow. It's really an honor and a privilege to be here with all of you on this momentous occasion. Momentous for EUMETSAT, for ESA, for industry, for Europe, and indeed for all of humankind. I want to give a shout out to John Lee and my other NASA and NOAA colleagues who are here tonight, but more importantly, they're the ones who provided the AMSU and the AVHRR and the SEM2 instruments on the MetOp-C payload. Speaking to all of you and many others who aren't here, congratulations to you and to your families and your friends, all of you who made it possible to bring MetOp-C over the years to fruition. So let's think about the mission ahead. In addition to improving weather forecasts, in addition to teaching us about our planet, in addition to advancing science in so many ways, you and MetOp-C stand as monuments and shining examples of what humans as a species can do when we work together. So go MetOp-C, and congratulations to everyone.
Thank you. Thank you, Mike. And do join the lineup. We have, no, please do stay. Please do stay. Please do stay. No. We have space for you and for one more speaker. And his name was mentioned several times already, Nicolas Chamusset, Airbus Executive President, Space Systems.